All right, so today is Wednesday, the 16th. I'm going to give you a couple minutes to work on the warm up. I'm going to go over the factor by grouping. Then I'm going to do factor and trinomials, and you're going to meet with your partner to finish up the animal project. Okay? All right, here we go. To figure out what the K is of this graph, you just substitute the value that you have, which is Y. You know what Y is, so plug it in for Y. F of X is the same as Y. So you're going to plug in negative 13 for Y or F of X to figure out what the X value is. When you do that, you solve for the equation by isolating the variable X to figure out what the answer is. Here, given the explicit, this is the equation. Explicit means you can substitute a number into the equation to get the direct answer. You don't need the previous number to get the next number. That's recursive. So they're saying find the first five terms. So you're going to substitute one in. Okay. So you got G of n or G of 1 is equal to 23 minus 9 times 1. Then you're going to do n is equal to 2. G of 2 is equal to 23 minus 9 times 2. Then you got 3. Then you got 4. And then you got 5. I'm going to put 5 down here. Okay. And you solve these, and that will give you your next 5 terms. First term, second term, third, fourth, and fifth. The 0 number is the starting number, which is 23. So they're not asking for that number. They're asking for the first 5 terms. 1, 2, 3, 4, and 5. Any questions about the warm-up? Today's Wednesday. We do have tutoring today. For Math 1, please make sure that you finish your animal project, that you work on that. That's due Friday. If you have makeup work, please make sure you get your makeup work in. That's it. Shh. Any questions about what's due this week? All makeup work, 11:59 Friday.
Yes,
ma'am. Okay. Yesterday we worked on factor by grouping. Please, let's look at that page, please. All right, let's complete. Yesterday we went through factor by grouping, so let's do this together. Make sure we got this right. When you're factoring by grouping, you look for GCF for all 4 terms first. You can only do factor by grouping when there are 4 terms here, okay? Just for 4 terms only. There is not a GCF for all 4 numbers other than 1. So you're going to use factor by grouping, which means you're going to find the GCF for the first 2 and the GCF for the second 2. So out to the side, I'm going to write the prime factorization for the first 2 terms. So I'm going to break down 12. What 2 numbers multiplied will give me 12?
2 and 6.
2 and 6. I'm going to circle 2. It's prime. Then I get 2 and 3. The prime factorization for this number is 2 times 3 times n times n times n. N to the third is n times n times n. When you break down 4, that's 2 times 2 times n times n. Now you're looking for the greatest common factor. They have a 2 in common, another 2 in common, an n in common, and a second n in common. So the GCF is going to be 4n to the second. So now you're going to take this 4n to the second and you're going to think, we're just doing these two numbers. What can we multiply times the 4n squared to give us 12n to the third? And see what's left? The 3n. So we got 3n here. What can we multiply times 4n to the second to give us 4n to the second? 1. Okay, don't have anything left, so automatically it's 1. So now we're going to find the GCF of the last two terms. We'll put that over here. 3n and 1. They're both prime. This is just 3 times n, and this is just 1. The GCF is just going to be 1. Okay? When there's no GCF, the GCF is automatically 1. So we got a positive 1. What can we multiply times this positive 1 to give us a 3n?
3n.
3n. What can we multiply times 1 to give me this 1?
1.
So now, when we look at this, we notice that these two terms are being multiplied by the same binomial. So we're going to take these two terms and put it in parentheses together, just like we did on yesterday. And right beside it, we have 3n plus 1. If we were to remultiply this back out, this would be 4n to the second times this, which is this line. And this would be 1 times this parentheses, which is this part of the line. Okay? So these two factors, when multiplied together, is going to give us this polynomial. These are the factors for that polynomial. Factors, not factoring. Sorry, y'all. Any questions about how to do number 4? Let's do number 5. Everybody should have that sheet, right? Yes. Do you need another one?
I wasn't here yesterday.
Here. Oh, no, that's not the right one. Looks just like it, Lord.
Miss Rich, can I get one?
Yeah.
I got one.
Anybody else need it?
I do.
No. Can you pass this back up? Can you pass this back to Ian, please? Anybody else? You need one? Pass this back to him. All right, here we go. Number 5. M to the third minus m to the second plus 2m minus 2. See if you can do this one on your own. Okay, so we first look for, these are the steps here. You're going to look for GCF first, okay? So look for GCF for all 4 terms. There's not a GCF for all 4 terms, okay? So then you factor it out by grouping. That means that you're going to find the GCF for the first 2 and then find the GCF of the last 2. So the first 2 terms, we list the prime factorization for them. So this is going to be m times m times m. This is going to be -1 times m times m. So GCF, what do they have in common? They have 2 m's in common. So your GCF for the first 2 terms is m to the second. So we take out an m to the second. Okay, what's left? Just m. This is left, m. Look, m to the second times m gives us this m to the third. What can we multiply times m to the second to give us a negative m to the second? Very good. Look, and it's a negative 1 left here. So this is going to be minus 1. So we did the first two terms. Now we're going to factor these two. We're going to do the GCF of these two terms. So we have positive 2m and negative 2. This is 2 times m. That's the prime factorization. For this, it's negative 1 times 2. That's it. What do they have in common?
2.
They have 2 in common. So GCF here is what?
2.
2. So we're going to take out a positive 2 plus 2. What can we multiply times this 2 to give us a 2m? M. And notice how m is left here. What can we multiply times 2 to give us a negative 2?
Negative 1.
Negative 1. So we're going to put minus 1 here. What do we notice about these two terms here? What do we notice about them? What do we notice about these two terms here?
They're the same.
No, these are not the same.
Oh.
They're being multiplied by the same binomial. So since they're being multiplied by the same binomial, you could put them in the same parentheses together. And then have it being multiplied by the same binomial. These are my two factors. Why is that okay, Ms. Reyes? Because when you multiply these two binomials, you're going to multiply m squared times m minus 1, which is this right here. And you're going to multiply 2 times what's in the parentheses here, which is this part of the line right here. Okay, so these are the two factors that if you were to remultiply them together, this would be your answer. So these are the two factors for this polynomial. Any questions about that? Anyone still copying? Okay. We'll pause. Try number 6 while we're waiting, please. Number 6, okay? Let's do it. Let's do it. Do, 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 do. Yes.
In that part, like, wherever you're dealing with the, I don't know what it's called. Whenever you found the GCS of the number, do you combine the negative and then, like, normal them together?
You have to kind of explain. You know what in your mind what you're saying, but you have to articulate it so I can understand it. Because I don't understand what you're saying.
It's hard to explain it. The negative 1 and the 2, do you multiply those together if those are the last two numbers left?
Yes.
Okay. Because I wasn't sure.
Yes. All right, ready? All right, here we go. You have to find the GCF of the first two and the GCF of the last two. Why, Ms. Reyes? Because there is not a GCF for all four. Okay, so you do the first two and the last two. That's called factor by grouping.
Yes.
So the first two, we're going to find the GCF of the first two. The prime factorization for the first number, this is prime, so we got 5 times n times n times n. factor out the negative first, so that's -1, and then break down the 10, and that's going to be 2 times 5. And if you can't see it, draw a factor tree. Then that's going to give us 2 ends. Now we're looking for all of the factors that they have in common. What factors do they have in common?
5 and 2 ends.
5 and 2 ends. Okay? So the GCF here is going to be 5n to the what?
Yeah, 5n squared.
So we take out the 5n squared from these two numbers, because that's what they have in common. So what can be multiplied times the 5n squared to give us 5n to the third? Just n. And notice how there's just one n that's left. Okay, what can we multiply times the 5n squared to give us this -10 n? -2. Okay, and notice how it's -2 left. And this is what you were talking about. Do you multiply those together? Yes, you do. All right, so let's look at these two. You got 3n and -6. We're going to list the prime factorization for this number. This is prime, so it's 3 times n. This is composite. We take out the negative first. That's -1. We break 6 down to 2 times 3. 2 times 3 is 6. Those are prime. What is the GCF for 3? They have a 3 in common. So we take out a +3, and we're left with what number can be multiplied times the 3 to give us, listen, you don't even know what we're doing. No, understand what I'm saying. I didn't say you didn't write it down. I said you don't understand what we're doing. 3 times what is going to give me 3n? And then 3 times -6, 3 times what is going to give me -6?
-2.
All right, so now what do we do? Yes.
Now you look to see if the numbers multiply, the binomials are the same.
Okay, so we notice when we look at this line, we notice that these two terms are being multiplied by the same binomial. So we can put them in a parentheses together. They're being multiplied by the exact same binomial. So beside it, we're going to put that binomial. And these are our two factors. When I multiply these two binomials together, I get this polynomial as an answer. Okay. All right, I need you to do number 7 here. Let me circle the ones I need you to do. Number 7, number 8, number 10, and number 13. 7, 8, 10, and 13.